So I'm going to make a quick video. This will be video one in a series on how to use Fusion 360 for doing milling with a Shapeoko. So I'm going to show some pretty basic stuff in this video. This is kind of an introduction to somebody who is just starting to use Fusion 360 for milling with a Shapeoko. So some pretty basic operations, show how to get the machine into Fusion 360, show how to create a setup, and show how to create a milling operation. So I'm going to start in design mode to create something pretty basic. I'm going to turn on the visibility of the origin, right click on the plane here, and click create sketch. From there, I'm going to create a basic shape to mill, which will be a rectangle that's 100 by 150. And then from the sketch, I'm going to select the profile and then extrude it. And I'm going to extrude it out by 50 millimeters. Actually, let's make that 25. Once you extrude a sketch, you'll have a three-dimensional object, and you can start creating sketches on the surface of that. So I'm going to create a couple things that I'm going to demonstrate milling with. I'm going to create a circle. Make that 40 millimeters. And it'll also create a rectangle. I'm just making some basic shapes as examples. I'm going to click both of those profiles, and I'm going to extrude those down by -10. And because the end mill is round, I'm going to give it a break, and I'm going to round these corners. Should be good. Alright, so now I have a basic shape that I can mill. So now that I'm going to mill, I'm going to go down here to manufacture. And then if you're just starting out and you have not yet added a machine, you're going to need to go to Manage, Machine Library. And you'll see that I already have the Shapeoko XXL in here. And you'll see that I already have the post processor. So Fusion 360 comes with the Carbide 3D post processor already included, but you can go to cam.autodesk.com/HSM posts, type Carbide here, and get the more recent post processor directly from Autodesk. When you first go into this machine library, you will not have any machines. So what you're going to do is click this Create New, and then click Milling. That'll bring up this dialog. But rather than start from that one, I'll just show you what those settings are. And this is going to be, like you just saw, the same box that pops up when you hit the plus. And I'll just walk through the settings that I have. You don't have to change a lot in here. You're going to want to put the description, the model, the vendor. These values are purely just so that you can identify that machine here in the listing. So you don't need specific values here. You just need something to identify it as that Shapeoko machine. The dimensions you're going to want to get from the Carbide 3D website for your particular machine, whether it's a XXL, XL, or just a regular Shapeoko 3. Under capabilities, you're going to want to put milling. You're going to want to get some of these settings. None of these down here really need to be changed from the default. You might want to put a maximum feed rate in here, but you know, these aren't as important, especially since you're going to be setting these in your tools anyways. Workpiece, you're going to want to put the area that is actually millable on the Shapeoko. So this is going to be smaller than the actual work area that you put in the dimensions here. Nothing needs to be changed under kinematics. You can leave all of that the same. Nothing needs to be changed under spindle. If you would like, you can set the minimum maximum for spindle speed, but if you leave it at 0, 0, it will still allow you to set a spindle speed faster than that without any warning. Nothing needs to be changed for machining time. Coolant, make sure none of these are checked unless you have some form of coolant added, but that's pretty challenging to do on the Shapeoko. We'll talk more about that in a future video. Click here on post-processing. It will take a second for this to load. And this is the most important part of the settings. This is where you're going to select the post-processor. If you click on System, you'll actually find the carbide3d.cps under the drop-down, or you could click Browse, like I did, and use the downloaded one, like I mentioned earlier, that you can be found on this website here. So once you have the post-processor selected, you can really just say OK, because these are left as defaults. So once you've added the machine into the library, you'll be able to use it again and again. You only have to add it once. So the next thing that needs to be done, and this has to be done for each time you're setting up a series of operations, and this needs to be done. If you think about setups, if you're machining the top of something, and then you're going to machine separately the other side of it, those would be done as two separate setups. Each setup is specific to the orientation of what you're milling, and so I'm going to add a initial setup, and it's just one setup for the top of this because this is all that needs to be milled. I'm going to say new setup here. From here, you're going to select that machine that you added, and you're going to see that here, and you can just go ahead and select that, and that machine will be there. You'll have milling here. For the sake of being able to mill things top, bottom, multiple sides, and really kind of think about the orientation in the way that the Shapeoko works, you're going to want to select this second option, and then that allows you to flip the z-axis if you want to mill the other side of an object. So you would set up, you would create one setup with it not flipped, and then you would create another setup with it flipped. For now, we're just going to use it as is. The next thing you want to do is select the stock point, and this is an important part of getting this right. So one of the things you're going to want to pay attention to is this up here. So as you can see, we're currently looking at the model from the back. So we're going to want to spin that around, and this is the front, and so this is going to be the same orientation as your machine. So when it says front here, this is going to be the front of your Shapeoko. Top, this is going to be the right. So this is going to be the same orientation that your machine is in. And so if you want to do your 0 from that front left corner, you click box point, and you're going to want to click that front right top corner. So that's going to be the top of your stock at the very corner. So you're going to zero out at that very corner, just like you would with Carbide Create. And so once you select that box point and you see that Y is going to the back of the machine, X is the X axis moving side to side, and Z is the router actually moving up and down. You want to make sure that the orientation of those coincides with those directions that you would expect. And so remember that when you place the stock on your Shapeoko, that this is towards the Y is going to be going towards the back of the machine, just like the axes are labeled on your Shapeoko. Okay, so normally, if you only have one body, it'll auto select that here. If you have multiple bodies in the scene, you may need to select which body that you actually want to machine here. But since it only had one body in the scene, it auto selected that body. Here under stock, you're going to see the actual dimensions of the stock that it's expecting to mill. So if you have stock that's larger than the model, then you're going to want to add those margins here. So if your stock is exactly the size of the model, like say you have a block like this and you're cutting out of it, you could say relative size and set 0 here. If you want to add a little bit of offset on the top, just so that you're sure that the milling actually begins kind of above or right on the surface, you can do so. If you're, like I said, if the stock is bigger than the model that you're going to mill, then you're going to want to add that extra stock here. And so, for example, if the piece that I'm milling is 20 millimeters larger, or actually 40 since it adds it to all sides, you can do so here, and you'll see, and you want to, when you measure your stock, you want to measure it up here. The other way to do this is to do fixed size and just put in the numbers that you measured for your stock. You can also do, let me see, relative size, and then add stock to all sides, and then add just the offsets for, say you have a piece and it is 100 millimeters depth, but it is a longer board, and so you're going to want to add more to just the X. And so you would put like 50 here, and see, you can see the additional stock here. Say that the board was really long, and you just wanted to mill the end of it, you put 500 here. I'm going to keep this simple and just do no additional stock at all. For post-process, since the post-processor is already configured in your machine, there's nothing here that you really need to change. So now that you have a setup, you have what you need to actually start adding milling operations. And so the difference between 3D and 2D is really, and people get this confused, they think that because they're kind of going multiple depths in the material that it might be 3D, but 3D is really, say the bottom of this this pocket was curved. Say it was like a bowl and it had like a concave shape to it. That's when you would need 3D. But 2D still has the ability to step down or do depths of cut as it goes down. So you'll see kind of what you might be familiar with the term depth of cut. You'll see that as step downs, and you can do that with 2D operations. These are both going to be 2D operations. Even if this had this hole and then a hole inside of it, that's still a series of 2D operations. Like I said, the 3D operations are only really where there's a curve. If say you were trying to do what they would call like 2.5D, where it's like a face that you're trying to do uh, if there was a face that you're trying to do like a scallop or you know, like a contour, kind of to carve out that three-dimensional object. So we're going to do a 2D, and I'm going to do two different operations here just to kind of show what we can do here. So there's a 2D contour, and what that is you can contour the perimeter of something or the inside perimeter of something. You can use this for cutouts. So if you had you know, maybe a half-inch piece of plywood or MDF, and you wanted to cut a shape out of that, that would be a contour. So let's go ahead and do that. So let's say you know, there was some extra stock here. I could actually select this perimeter. Let's go back. I'm going to show you how to select a tool. So every operation, you're going to need you're going to need to select a tool, and you can download these tool libraries for Carbide 3D various places. I'll include some links in the description for the video. I also have some custom tools here that has you know, custom feeds and speeds for that particular tool. You can find tool libraries from the various manufacturers of end mills. If you know, this Amana one has quite a few. This Whiteside has quite a few. They basically have these tool libraries for every probably almost every end mill that they create. So you can just use these very quickly, and they're already set up. They often already have the right feeds and speeds, which is really useful. But I'm going to go ahead and I'm going to go in here to the Carbide 3D and use an end mill that's included with the Shapeoko that most will be familiar with, which is that 1/4 inch 201 end mill. Let's select that. You'll see here, now that I've selected this tool up here, that I'll have the feeds and speeds for this. And what you're going to want to do is configure this based off of you know, your material that you're cutting. So you can find the feeds and speed table that has recommended feeds and speeds for different materials. Just if you even do a Google image search for Shapeoko feeds and speeds, you'll see a lot of those tables that show you the recommended, especially for the 201 end mill. I already had selected that contour, and that's basically going to be the edge of any body that you can select. I could select this top contour, the bottom contour. If you're going to do a contour operation where you're cutting something out like this, you're going to want to select the bottom contour to do so. The next thing that you're going to want to configure is the heights, and you know, this is important to be able to actually you know, properly retract above your stock. Generally don't need full 10 millimeters of retraction for clearance. You're going to want to make sure this top height is the top of your stock, and then this bottom height is the selected contour. So that's that contour along the bottom, and it's going to show you those here visually so that you can kind of get an idea. And you can even, just to make sure that you've got the proper clearances, you can, you know, rotate around this and get a good look. The next thing to configure is passes. So here under passes, you're going to want to select multiple depths. It's important that you don't try to cut something out all in one go. You're going to want to do some step downs, and this step down right here is the same as depth of cut. So if you look at the tables that I mentioned earlier about feeds and speeds for the Shapeoko, it will mention DOC, depth of cut, and so that's the number that you're going to want to get here. You can leave a lot of these other settings alone. the real one that you're going to want to pay attention to is this depth of cut. You don't need to change a whole lot else here. Over time, you're going to learn kind of what you need to tweak here to get better finish. Speed things up a little bit. But the key thing here first, for at least for doing a contour operation, is to make sure you have the right step down. You don't need to change a lot here. Eventually, you'll start tweaking the settings here. The main thing here is if you had some contours that were close to something else, and you wanted to make sure that that lead-in didn't cut away the material that's like from a neighboring cut. And also you can tweak these settings to get faster machine times. You can also select this to keep the tool down, so when it's going around and making each pass, it will fully retract unless you click keep the tool down. So I'm going to go ahead and click that, and then click OK. It's going to spend a couple seconds here, depending on your operation. Could take longer, and it's going to show the percentage here. If you highlight this, you'll actually see it building this out. So these lines that you see here, those are the tool paths. So it's much like in Carbide Create under Simulate, it'll actually show you where the tool is going to go. It'll also show you these are the lead-in operations. It's doing a helical approach, lead-in. If you want to actually replay this, you can go here and you can go to Simulate. And this is going to be similar to Carbide Create, where you can actually simulate it, and you can press play here to actually replay, and you can see the tool actually going through the operation. You can speed it up using this. You can select along in different places in the operation here. You can turn off the toolpath so you can just see the stock being removed. Since this is already the size of stock that I'm going to cut from, I'm going to go ahead and remove this operation. I just wanted to kind of show that outer contour operation in case you were cutting out the material. I'll do a future video that shows how to use tabs, because tabs are an important part of doing cutout operations, so that the piece isn't broken loose while it's cutting it out. You want some tabs that are left there to hold it in place, and then you can remove those tabs with a bandsaw or even a handsaw once the piece is done. So the next thing I'm going to do is I'm going to show two operations here. I'm going to show a 2D pocket. I'll start with that one. I'm going to select the tool again. Once you actually use a tool in a particular file, when you go back in here, it's going to have that tool already in this list, which is convenient, so that you don't have to go and find it in the library again. So I'm going to go ahead. Seems to be loading here for a second. I'm going to go ahead and select that tool. And I'm going to select the bottom face of this. So there's multiple ways to pocket, but what you're going to want to do is, with most 2D pockets, you're going to want to select the bottom face of the area that you're trying to pocket. So I'm going to go ahead and select that. Again, you're going to want to make sure the stock top is selected here, and then the selected contours are selected here. Most of the time that's what it defaults to, or maybe all of the time. Um, so you don't really need to edit that very much. I often turn this to 5 just because you know, I don't need it to go all the way up. Sometimes that saves a little bit on machine time. Um, Now, with this pocket operation, there's going to be a new important setting here, which is step over. So this is how much you know, as it's pocketing, how much it overlaps the previous toolpath, and so this is going to affect the finish. This is going to affect how much load you're going to put on the bit, and so, you know, having a step over that's too high with a small bit could break the bit. And I think the general rule here is, you know, half the diameter of the end mill that you're using. But just to be safe, I'm going to put 3 millimeters here. And then I'm going to uncheck stock to leave. So stock to leave is a setting that allows you to leave some material so that another operation using rest machining can just clear just that remaining material, which will give a better finish. But for most operations in wood on the Shapeoko, especially if you get the good step over and multiple depths with good step down, you don't really need this second operation. So you always want to make sure, like I said with the contour, that you select multiple depths, so it doesn't attempt to plunge the end mill down and try to do this all in one pass. And then again, the step down is the important setting here. You want to make sure that you have a step down that is not going to put the end mill too far down in the material as it tries to move, you know, during its feed. And then, you know, like I just set this step over. So getting these two correct is going to give you, you know, your control of whether this is going to be a successful operation or not. Most of the other settings are really going to be the fine tuning, or you know, through experimentation you can learn more about them. But these are the two critical settings here. Underlinking, you know, for pockets, the keep tool down is already going to be selected. You don't really need to edit a lot of these. Again, these are things that you can play with over time, but they're not as critical initially. I'm going to hit OK. You're going to see that it's building that out. And so now you can see this tool path clearing out the material in this pocket. And so that looks like a pretty good tool path. Now I'm going to add a second tool path for this other area. I'm going to do adaptive clearing. And now the difference between adaptive clearing and, say, a pocket is adaptive clearing is designed to put less stress on the tool, and so it's going to come in with the tool at angles that are optimized to put less load on the tool. So that you'll see, because I already have an operation with that other tool selected, I don't need to select it again. It's defaulted to that. I'm going to, again, select a pocket for this. This time I'm going to select the bottom of this one. Heights, again, I'm going to reduce this to 5. I'm going to verify that this is the top and bottom of the stock, or not the bottom of the stock, but the bottom of the selected contours. Now this is what I was talking about earlier. This is optimal load. So this number, whether it's low or high, is the amount of pressure it's going to put on that end mill as it moves through. So this is related to step over. So just like it says here in the description, this can be considered the step over amount, but adaptive high-speed machining will vary the step over to reduce overloading the tool. So this is, you know, you could put a number that you would think of as step over, like the, you know, half of the diameter of the end mill, but this is really going to, throughout the operation, use this number to optimize the load on the tool. So it will vary, unlike step over on another operation. You don't really need to change a lot of these other. You can experiment with them later. Again, I'm going to uncheck stock to leave. I'm going to, again, make sure that I have multiple depths. I do not want it trying to go full depth in this. If this was, say, MDF, you might be able to do, a shallow pocket, or even the pocket I have here in one go. It's much safer usually to do it in multiple step downs. So I have this at 10 millimeters. I probably don't want that. I'm going to go ahead and just to make sure it's a nice clean cut. It's a little bit more waiting for the machining to finish, but it's going to be worth it for a nice clean adaptive clear. Linking. You don't really need, again, to change a whole lot here. This is something that you can fiddle with later to optimize your finish, or to make sure that you're not unintentionally cutting material. But for this one, there really is no chance of that. Or if you're just trying to fiddle with these settings to speed up the total machine time. I'm going to hit OK. It's going to spend some time doing that operation. And so it's hard to tell, but it's set this up, and you'll see these tool paths that cross across here. And the reason why is because it's actually always optimizing it so that when it goes against the wall to clear more, it's coming in at an angle that is optimizing the load on the end mill. So the next thing you're going to need to know to actually use this on the Shapeoko is how to do the post process. So I showed you how to simulate it. You're going to, often in the beginning really want to watch those simulations to make sure that it's not doing anything funky. It's doing what you expect. So there's after you've done that, so there's two ways to post process off of your tool pass. One of those is to post process just one tool path. So if I wanted to just do this one, and then later as a separate tool path do this one, or say on my Shapeoko I did not have a bit setter, I wouldn't have a mechanism to measure the length of the bit between two operations that had a tool change. So I would want to post-process those separately. But if I have a bit setter and I'm doing multiple bits, or if I have both of these are the same bit, I can actually highlight both of them by shift-clicking the other one, or I can actually right-click on the setup and do a post-process from the setup. If you right-click on the tool here, you can post-process just the tool. It's actually the same for simulate. So I can simulate just one, or I can click on setup and simulate both. You can also get the machine time here. We'll give you an estimate of how long this will take to machine. But I'm going to show you how to post-process these. So I'm going to select both of these. I'm going to click post-process. You don't need to change anything here. I'm going to click OK. And then that's going to have the ability to save this .nc file. This is the G code, and this is going to be similar to when you export your G code from Carbide Create. So this is going to save out a .nc file that you can load in Carbide Motion and run this operation. And like I said, this is post-processed with a post-processor from Carbide 3D that has the ability to do those tool changes with bit setter. So if you have a bit setter, it will prompt you for the next tool if you had multiple tools selected here, and measure that with the bit setter and continue those operations. So I can save that out and run that with Carbide Motion. I'm not going to show that just because most of you probably already have experience loading and running your G code with Carbide Motion. So that's the basics. I'm going to keep it to just that for now. Hopefully that was the right amount for the first video. And in future videos, I'll go into more operations and I'll show some of the more nuanced settings that you can do in here. I'll also have a video that covers adding more tool libraries and maybe I'll probably have a video soon after that that goes into some 3D operations. Again, though, it's wise to spend some time with 2D operations. A lot of things can be done with 2D operations. Spend some time with 2D operations before you jump to 3D. A lot of people tend to try to just immediately, mill something like this with, pocket clearing 3D operation when it's really not necessary. It's really a waste of of machining time, and it's it's just not the way to do these type of pockets. So those are the operations I'll show today. New video coming soon. Thanks.